Nenomatica, where mathematics meets YouTube excellence. Today we'll learn about polynomial expressions, their definition, and see some examples. A polynomial expression is an algebraic expression that consists of terms with variables raised to non-negative integer powers. Let's start with the definition. A polynomial expression in one variable is the sum of several terms with the same variable but different exponents, where all exponents are non-negative integers. For a polynomial with a single variable x, we typically denote it as p of x. For example, here's a polynomial in one variable p of x equals 4x to the fifth power minus 7x to the fourth power minus x squared plus 1. For polynomials with multiple variables such as x, y, z, and so on, we denote them as p of x, y, z, and so on. Here's an example of a polynomial with two variables, x and y, p of x and y equals x squared, y cubed, minus 5xy squared, plus 2xy minus 3. Let's break down what makes a polynomial. All exponents must be non-negative integers. Each term consists of a coefficient multiplied by variables. Terms are separated by addition or subtraction operations. Now let's look at some expressions that are not polynomials. The first expression, 4x to the sixth plus 15x to the negative eighth plus 1, is not a polynomial because it contains a term with a negative exponent x to the negative eighth power. The second expression, 5 square root of x minus x plus x squared, is not a polynomial because it contains a term with a non-integer exponent, the square root of x, which is x to the power of 1/2. The third expression, 2 over x plus x cubed minus 2, is not a polynomial because it contains a rational expression with a variable in the denominator, 2 over x. Let's summarize what we've learned about polynomials. A polynomial is an expression that contains variables with non-negative integer exponents, has terms combined by addition or subtraction, contains no variables in denominators, contains no fractional or negative exponents. Quick challenge. Can you determine which of the following expressions is a polynomial? 1. 3x to the fourth plus 2x to the negative second plus 5 2, 6x squared plus 4x plus 9 3, 7 square root of x minus 2x plus 1. Take a moment to think about your answer before we continue. Today we'll learn how to identify the degree of a polynomial expression. The degree of a polynomial is defined as the highest power of the variable in the expression. For example, in a single variable polynomial like x squared plus 3x plus 5, the powers are 2, 1, and 0. The highest power is 2, so the degree of this polynomial is 2. Let's look at more examples of single variable polynomials. For the expression 5x to the power of 12 minus 2x to the power of 6 plus x to the power of 5 minus 198x plus 1, the highest power is 12, so the degree is 12. 4x to the fourth minus x cubed plus x squared minus x plus 1, the highest power is 4, so the degree is 4. For 56x to the power of 23, the highest power is 23, so the degree is 23. For 5x minus 7, the highest power is 1, since 5x means 5x raised to the power of 1, so the degree is 1. For negative 8, there is no variable, which means we can write it as negative 8 times x to the power of 0, so the degree is 0. Now, let's discuss polynomials with multiple variables. For multivariable polynomials, the degree of a term is the sum of the powers of all variables in that term. The degree of the polynomial is the highest degree among all its terms. Let's look at some examples. For the expression x squared y minus 6x cubed y to the power of 12 plus 10x squared minus 7 y plus 1, let's examine each term. In x squared y, the power of x is 2 and the power of y is 1, so the degree of this term is 2 plus 1 is equal to 3. In 6x cubed y to the power of 12, the power of x is 3 and the power of y is 12, so the degree is 3 plus 12 is equal to 15. In 10x squared, the degree is 2. In 7y, the degree is 1. In the constant 1, the degree is 0. The highest degree among all terms is 15, so the polynomial's degree is 15. Let's go through more multivariable polynomial examples. For 6x to the fourth plus 8, y to the fourth minus 2x, y squared. The term 6x to the fourth has degree 4. The term 8y to the fourth has degree 4. The term 2x, y squared, has degree 1 plus 2 is equal to 3. So the degree of the polynomial is 4. 4x to the fourth y squared minus x cubed minus x y plus x to the fourth. The term x to the fourth y squared has degree 4 plus 2 is equal to 6. The term x cubed y cubed has degree 3 plus 3 is equal to 6. The term x y has degree 1 plus 1 is equal to 2. The term x to the fourth has degree 4. The highest degree is 6, so the degree of the polynomial is 6. 4 6x to the 14th minus 10, y cubed plus 3x minus 11y. The term 6x to the 14th has degree 14. The term 10y cubed has degree 3. The term 3x has degree 1. The term 11y has degree 1. The highest degree is 14, so the polynomial's degree is 14. Welcome to our lesson on finding the degree of polynomials. We'll learn how to determine the degree of a polynomial in one or more variables and work through several examples together. Let's start with the definition of a polynomial degree. For a polynomial in one variable, the degree is the highest power of that variable. For polynomials with multiple variables, the degree of each term is the sum of the exponents, and the degree of the entire polynomial is the highest degree among all terms. Let's look at our first example. We have the polynomial p of x, and y equals 4x to the fifth power plus 5x squared, y cubed plus 3x cubed, y to the fourth power minus 2, yx minus 6. Let's examine each term to find their individual degrees. 4x to the fifth power has degree 5, 5x squared y cubed has degree 2 plus 3 is equal to 5, 3x cubed y to the fourth power has degree 3 plus 4 is equal to 7, negative 2yx has degree 1 plus 1 is equal to 2, and the constant minus 6 has degree 0. The highest degree is 7, so our polynomial has degree 7. Let's look at our second example. We have p of x, and y equals 3x squared plus 4, y cubed plus x squared, y cubed plus x to the fourth power, y plus 2y to the fifth power x. Let's find the degree with respect to x with respect to y, and the total degree. The highest power of x is 4, which appears in the term x to the fourth y. The highest power of y is 5, which appears in the term 2y to the fifth power x. The total degree is found by looking at the sum of exponents in each term. 3x squared has degree 2, for y cubed has degree 3. X squared y cubed has degree 2 plus 3 is equal to 5. X to the fourth power, y has degree 4 plus 1 is equal to 5. 2y to the fifth power x has degree 1 plus 5 is equal to 6. The highest sum is 6, so the total degree of this polynomial is 6. Now, let's look at a more complex example where we need to expand the polynomial first. We have p of x, and y equals the product of x squared y cubed minus x times the quantity xy squared to the third power plus the product of xy times the quantity x to the fourth power y squared plus 1. Let's expand this polynomial to find its terms. First, let's correct and simplify what we're given p of x, and y equals the product of x squared y cubed minus x times the quantity x cubed y to the sixth power plus the product of xy times the quantity x to the fourth power y squared plus 1. When we multiply out the first product x squared y cubed times x cubed y to the sixth power is x to the fifth power y to the ninth power, and x squared y cubed times negative x is negative x cubed y cubed. For the second product, xy times x to the fourth power y squared is x to the fifth power y cubed, and xy times 1 is simply xy. So our expanded polynomial is p of x, and y equals x to the fifth power y to the ninth power minus x cubed y cubed plus x to the fifth power y cubed plus xy. Now let's find the degrees of each term. X to the fifth power y to the ninth power has degree 5 plus 9 is equal to 14, negative x cubed y cubed has degree 3 plus 3 is equal to 6, x to the fifth power y cubed has degree 5 plus 3 is equal to 8, xy has degree 1 plus 1 is equal to 2. The highest degree is 14, so the polynomial has a total degree of 14. The degree with respect to x is 5, and the degree with respect to y is 9. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. Nenematica, where mathematics meets YouTube excellence.